Hello. The title of my presentation is Why, What, How Line Mini App with AWS Serverless. I'm from Amazon Web Services Japan Ishimoto, a solution architect. So let me briefly introduce myself. My role is a solution architect. To the clients who run internet media services, I provide technical support. I'm here today from AWS today because I work together with Line to offer hands-on events combining LIFF, messaging API, and AWS. Also, we announced Line DX program with AWS, which is an offering and a partner program. With this experience, we decided to run the session online and serverless technology. Before going into the presentation, let me tell you some cautions. This presentation is based on the services and the prices as of October 28, 2020. Please refer to the AWS official website for the latest information. Although we paid a lot of attention to create the documents, the price information on the AWS official website is the official price and may vary from the information provided in this material. Okay, let's talk about main topics. Let me tell you the assumption of the audience. The audience today has some experience of a line front-end framework and a message API, or considers the implementation and have started the research. Likewise, the audience has some experience of AWS Serverless or started the research, therefore has some understanding of the technology. So, those who understand how to use but are not sure what is required to run it in production, we hopefully find this session useful to understand consideration and implementation methodology in the production. Therefore, please be aware that I'm not going to talk about the detail of each AWS service. This is today's agenda. First, I will quickly summarize Line Mini applications and the relationships with Line products. Next, why part, I will talk about advantages of AWS Serverless combined with Line products. Then what part, I will show you sample architecture and some consideration, and then how to implement. To be specific, in case of using serverless, especially Lambda, not only the logic but may other considerations exist. So I will discuss some of them and talk about a well-architected framework serverless applications lens that comprehensively covers those implementations, and wrap up. Now, let's review the Line Mini applications and the relations with Line products. What is Line Mini application? These are the web applications that run online. For developers, without developing Line native application, you can send push messages and include a payment system. For users, without downloading applications, you can enjoy different services via familiar Line interface. For business entities, based on the offline customer flow line at store, you can link users with Line account. By doing so, you can leverage the information across offline and online border and improve CX. This means to users, business entities, and developers, this product can offer advantages. Next, let's look at the relation with the Line developer products. On the official web page, it says that Line Mini application is a kind of LIFF application. All the APIs provided by LIFF are available. LIFF stands for Line Front-End Framework, which is a platform for web applications provided by Line. For example, acquiring user ID from Line platform, or providing functionality using Line users' information, or sending messages in place of users can be achieved. Line Mini application consists of LIFF and functionalities specific to Line Mini application. You can develop the Line Mini application starting from LIFF portion. Next, let's talk about configuration and the major functionalities of Line Mini application. As indicated in Figure 1 on the right, Line Mini application configured as web application has the header part automatically generated by Line and the body provided by HTML5 and LIFF. On top of providing functionalities as a web application, these have various convenient functionalities including message notification to service messages, stockroom, and embedding Line Pay and other payment system. In this session, focusing on LIFF and message notification functionality, so to speak, messaging API and many Line product, I will discuss how it works together with AWS Serverless. First, I will discuss the general configuration and the flow when using general LIFF and the messaging API. Let's start with LIFF. When an end user accesses liff.line.me/liff ID, which is liff URL, the user will be redirected to the endpoint URL, which is registered on developer portal. Then redirected URL arrives at the web application server in this case, and server returns web pages that includes HTML5 and LIFF. This is a very simple flow. Next is messaging API. There are multiple functionalities, and I will talk about reply message that works like a bot. End user, who is a Line user, sends a message to the official account via Line. Line platform then sends an event for webhook to the webhook URL, which was registered in advance. There are different events, including messages that contains text and images, follow and join the room. The events sent from the Line platform will be processed, but before that, we need to verify that the event was sent from Line. It is because as this API server needs to be available for public access and therefore a malicious user may send an event. How to verify? The event data sent from Line contains the hash generated by hashing the request body using a channel secret in XLI signature field in the request header, the orange letters in the middle. API server that received it uses the channel secret and body to generate hash and checks whether it matches the one sent from Line. Channel secret that is used to generate hash is known only to service provider and Line. Therefore, it is possible to verify that the sender is Line. After the completion of verification, necessary logic will be executed and a reply will be sent to Line platform. Also, in the earlier example, API server webhook ran the process synchronously. In order to avoid delay with subsequent event processing, it is effective to process asynchronously using a queue. Lastly, although this is just a sample, this is the configuration when using LIFF and messaging API. When a user starts LIFF application, LIFF backend server returns a web page that contains HTML5 and LIFF. The user can enjoy different experiences without installing an app. If you want to run an interactive process such as a bot, as I explained earlier, you can combine it with messaging API to provide the service. So far, I have discussed the overview of Line Mini application and the relation with Line products. Now let's cut to the chase. Why shall we combine Line Mini applications and AWS Serverless? Let me start with what the AWS Serverless is. Serverless doesn't mean there is no server. It means you don't have to be conscious of the existence of a server. To be more specific, a backend server is fully managed and offered as a functionality by AWS. Therefore, from the user's perspective, controllable server is not visible. Let's compare it with other configuration. For example, if you want to build an application on-premise, you will have a lot of considerations including racking for a physical server and managing hardware, installing OS, and applying patches. I'm sure some companies standardized all these tasks and run them quite efficiently. However, it may not be universal among all organizations. If you use AWS, for instance, EC2, you can offload the physical server-related tasks, including OS installation, to AWS. Also, if you use RDS, that is a managed service by AWS, you can offload DB installation into OS as well as patching to AWS. And serverless, which is the focus of my presentation. Customers can focus only on developing application. Building a system on which application will run and regular tasks such as patching OS that are all non-differentiating legwork can be performed by AWS. Also, price model is pay-as-you-go, meaning you will be charged only for what you requested. Therefore, you don't have to worry about the cost of the time with lower usage. You can focus on the most important development for your business. Probably what most of you want to build is not racks with neat cabling or grandeur clusters, but services and business logics. And you want to implement them quickly and get feedbacks from your clients and improve them. You want to run this feedback cycle. That is why you use Line, which offers convenient functionalities for both developers and users, and serverless technology with which you will have relatively fewer considerations when building services matches your requirement. So, please consider leveraging serverless technology for your backend development of Line products. Now, what are the considerations for combining AWS Serverless? This is a mapping of earlier configuration to AWS. Let's start with LIFF. If you want to provide LIFF, place static contents on object storage service called Amazon S3, and from CDN service called Amazon CloudFront, you can deliver LIFF applications. With this, even when accessing from different environments, you can enjoy high performance. Also, you can host the application which was built and managed combining front-end and AWS backend. With AWS Amplify is also an effective option. Also, if you want to include dynamic contents in the distributed page, you may send a request to API Gateway Lambda. This can be a possible use case. Next is a messaging API. You can use this configuration as well. I explained the process flow earlier with user's action. An event will be sent from the Line platform to the pre-registered endpoint for webhook, in this case, API Gateway endpoint. After receiving the event via API Gateway, Lambda verifies signature and then puts the event data in SQS. With the trigger from SQS, Lambda will process the event asynchronously. I mapped the earlier configuration again. This is how it looks. As a LIFF backend, we have CloudFront S3 or Amplify, and as messaging API backend, we have API Gateway, AWS Lambda, Amazon SQS. These are all modern architectures offered as managed services with which you don't have to be conscious of the server existence. Okay, in order to implement backend for Line product, all I have to do is implementing 2 Lambda functions. Is it true? Maybe not. In the real world, on top of business logic, there are a lot of considerations, including authentication and authorization, which are security related, canary release, which is CI/CD related. As a performance perspective, designing of cache and scalability, and monitoring, logging, error handling, which are about operation. In addition, as to non-functionality requirement other than the business logic. Even if you design and implement them once, it is not the end of the story. In operation, you need to run improvement cycle just like you do with business logic. Like this with serverless, there are considerations other than logic. So I hope you understand that you are not free from all the considerations to run the system after having implemented the logic. I wish to explain all the considerations, but with the respect of time, I will focus on these topics alone about the implementation. So first, how monitoring? AWS provides various services and tools for operation and management of a system. For example, we have system managers to support efficient operation, cloud formation to realize infrastructure as code, and many others. Most of them are the managed services. In the area of monitoring indicated on the bottom left, we have AWS X-Ray and Amazon CloudWatch. Monitoring consists of metrics monitoring, log analysis, and request tracing. As I explained earlier, AWS has Amazon CloudWatch and AWS X-Ray for monitoring. What can be monitored are resource usage, performance of applications, operation status, and so forth. You can get the overall status of the entire system. To realize these tasks, you don't have to set up, manage, and scale your own monitoring system or infrastructure. Now, I would like to talk about metrics. What are the perspectives necessary for serverless? For example, regarding Lambda functions that you run in production now, do you capture the following information correctly? Average process time of Lambda, runtimes, and the number of errors? To understand the current status, to find issues and improve, in serverless applications, you need to accurately monitor how your codes run. Let's look at the metrics for AWS Lambda. Those who use this regularly may be familiar with this screen. If you run the Lambda with Management Console, you can view this screen. Preset test events were passed to Lambda, and succeeded or unsucceeded will be displayed on the left top. This screen says succeeded. If you click the detail under the run result, you can see the details of this test. Like this, the result of run, runtime, memory used, overall information can be displayed. Also, I will explain this later. You can also view the standard Lambda function output, which was output to CloudWatch log, which is at the bottom of the screen. Also, some information such as run count is displayed at the end of the log. Having said that, as naturally may be, it is difficult to check all the information of Lambda in this way. In reality, you will check the metrics that Lambda issued. These are the default metrics that Lambda issues. For example, with invocations and errors, you can check run counts of Lambda and abnormal completion of Lambda. You can check the duration of Lambda run with duration. With these metrics, for example, you can check the changes of run count in different time period or run duration at a certain point of time. For instance, you can check whether the duration increases during the period when call increases, and if so, what is the bottleneck? You can also find out whether runtime or error rate increase around deployment.
Now, how to confirm this? AWS Lambda Management Console has a standard feature to confirm metrics. Each metric's transition along the time is depicted with a line graph. You can visually check service status. If you hover the mouse on the given graph, the metric's value at the time is popped up. If you press the Add to Dashboard button, the currently displayed Lambda function metrics is registered to Amazon CloudWatch dashboards. CloudWatch aggregates the metrics for your reference. Lambda metrics are added to Amazon CloudWatch dashboard service. Different services or multiple Lambda function metrics are added to dashboards, so you don't have to switch screens for service operation since you can check service metrics comprehensively. I recommend you to use these CloudWatch dashboards. Next, let's talk about logging. When Lambda function has necessary authority, it can output the log to CloudWatch logs to save the standard output result of function code. It can use language standard output feature as it is. When the codes are implemented in this way, this case Python is used and it is implemented as print hello world. The result of output to CloudWatch logs are confirmed in this way. In the middle, you can see hello world. Parts of execution detail metrics are also output in this way, duration or memory usage. However, for actual application operation, it is common to use logging library like Logger. By using it, you can insert log level timestamp request ID to each log record, and this helps to increase tracking ability for troubleshooting. Right-hand side is an example, import logging, and at each log level, log output is set as print-like. You can confirm an execution result in this way. At output, you set log level, timestamp, request ID, and standard output. They are displayed as a log record. If you compare this to the print hello world, this log is more helpful for operation. To use logs further, I'd like to share extended library for Python. This is AWS Lambda Power Tools Python. The orange box at left, the core utilities of this library, which are tracer, logger, metrics. Tracer sends execution status of code for distributed tracing services such as AWS X-Ray. By using metrics, application-specific information such as sales volume against request is handled as custom metrics and input to CloudWatch. With regard to logging, extended logging mechanism is offered as a logger. There are several types of log structures. Raw log is inserted with log level, but it outputs logs as flat text. Semi-structured log, which field is structured and searchability is enhanced, but log level is output as text. Structured log, which all fields are structured and suitable for analysis. These are not all, but I'd like to elaborate implementation, output, and issues respectively. First, raw logging. Reading logging library and output via a logger. Very simple implementation. It is easy to read log. But if metadata, such as statistic information, is inserted into a log field, it is impossible to search by designating a field. It is not suitable for an analytic purpose. Next is semi-structured logging. Structured object is added to the previous logger function. This is the output result. These issues would be cumbersome work to implement structured object into codes, and there would be a need of a structured log level. Now let's look at structured log output. First, let's look at implementation. Create formatter for a structured object. It is around the middle of the screen. Designate add handler as an output method. With this, the log is something you expected. Log output within the logic is logger.info only, so it is simple, but due to the structured code, the code gets complicated. So you may think to use nice library. Then here comes AWS Lambda Power Tools Python. Install with a kit and upload it with application code or define it as a Lambda layer. As you can see here, logger structure implementation is managed externally and codes are very simple. By giving a service name, searchability is enhanced when the analysis is performed across multiple logs. In this example, you can see payment in the code. Service and payment are included in the log. By using decorator, which is a predefined power tool, context information at the function side is able to be output without additional implementation. This session doesn't focus, but Lambda has a cold start execution pattern which generates backend container or performs code loading process. For example, if you use this decorator, the status of function execution is output to logs called start true, or a function, memory size, request ID are output. I have repeatedly mentioned searchability for example, with CloudWatch Logs Insight, log search result is visually offered. Now you see the number of Lambda execution at certain period visually here. If you add cold start one condition to a filter, it is possible to search target logs from structured logs, so only cold started execution is output. It is possible to add conditions to each service, such as payment. In this way, if you use this tool, the way you can use the logs would be expanded. Not all applications always require this feature, but if you face log usage issues, please try this expanded library. I have covered monitoring and logging. Now I'd like to talk about error handling. From the previous configuration diagram, the Lambda part has been extracted. Lambda has several execution patterns, but in this configuration, two patterns are shown. Synchronous execution of Lambda function via API gateway after API is called by client. And the other pattern is asynchronous execution for a client side by using a message trigger, which is put on the Amazon SQS. I will explain both in detail. The first pattern, when Lambda is called synchronously via API gateway, the Lambda function waits the end of execution since it is synchronous. Once the function execution ends, Lambda returns the response, such as function version or added data. At the time of error, the behavior depends on how the client calls. Lambda does not automatically retry. The source of calling side would handle errors based on responses. The scenario would be the case when the event source execution should be returned. For instance, when the value has to be returned to client side by Web API. Next, pattern 2. Lambda is regularly polling to check whether there are any messages or events put into a queue. A user doesn't have to pay attention on this. If there is a message in a queue, the function prepared by a user is executed. About error handling, a client which executes Lambda, his work is done when he has put messages or events into a queue. So the retry has to be handled by an execution side, Lambda side. I am going to deep dive on this pattern. To execute Lambda by SQS, there are some points to pay attention. On this page, I will focus on who will retry and when retry is failed, where event data go. There are different causes of function errors. It could be logic issues or data issues, or external service which is called by a function could be throttled, or a function itself is throttled. In case of this Lambda executed by SQS, Lambda will retry for the number of times which is specified in the maximum number of retry. If there is an issue of data or logic, it won't work well regardless how many times you retried. That's why the maximum number is set. When the max is reached, the message is sent to dead letter Q for escape. With this, when the process doesn't succeed, you can try up to the maximum number and you can escape the subject event data. This is the image of dead letter Q. When the maximum number of retry is reached, the event data is sent to dead letter Q. There is Lambda for a dead letter Q. When a message is registered in the dead letter Q, post-process is implemented such as Slack or email notification or issuing ticket or data addition to dedicated database. With regard to idempotence, Lambda guarantees execution at least once when a client calls Lambda. So there are cases when multiple executions are performed with the same event. When an error, like external call, occurs in the middle of logic and the entire function is retried, the specific process within the function could be executed again with the same event data. So idempotence has to be addressed by user-side calls. There are multiple ways using status management table, condition writing, implementing guaranteed transaction. One good example is to use unique key included in the event data for the process control. The middle bullet I'm referring. To be more specific, check whether unique value exists in the table, and if it exists, a corresponding process is skipped and finish Lambda or corresponding process normally. If there is no value, unique value is entered and the normal execution is continued. This is one way of implementation. When Lambda error occurs, following points should be considered: who will retry, where the event data go, and the idempotence design. I have explained monitoring, logging, and error handling. You might be worried about there are more things to be addressed like security, deployment, performance design, and cost optimization. And we have something for you. AWS Well-Architected Framework Serverless Application Lens. Well-Architected Framework was announced at a global conference, reInvent, in 2015. It intends to make your AWS usage best practice efficiently. To be more specific, it is a white paper which contains points you have to pay attention or design principle based on AWS solution architect's experience to architect workloads in a real world with customers. The white paper consists of 5 pillar-based questions and design principle best practices. By answering questions, you can evaluate the risks of your workloads and identify things to be improved and address them based on the white paper. The point you should understand is that this tool visualizes these risks, but doesn't make everything perfect. There is no perfect system. So you can focus on things necessary for your business and improve them. Well-architected framework is improved every year. In 2017, Serverless Application Lens was announced, which is serverless specific application. Here it is. If you search AWS Serverless Application Lens, you can get a PDF of Japanese version. This is a big volume document, but very practical. Please refer it if you have not read it yet. This is how to use it. From AWS Management Console, you can answer questions. For example, this is one of the questions in the area of operational excellence. I enlarged them. Understand metrics without complicated setting and analyze them and issue alerts. Use distributed trace and context is added to codes. Structured and centralized logs. Use application business operational metrics. Not applicable. In this example, 3 items in the middle are checked. Not only Line Mini application, but serverless application in the real world, it tends to have complicated architecture like this. Serverless is very convenient and powerful, but compared to monolithic application, it has more components. Because of that, by using distributed trace, you need to identify up to which process a request is processed normally and where the issue occurs, or analyze logs by multiple components comprehensively and identify the root cause or analyze the business impact when the issue occurs. It is important to evaluate what is covered. Once again, I post the well-architected positioning. It consists of design principle and best practices in a style of questions and answers. With this, it is possible to understand the current risks and things to be improved. Also, this is not a one-time work. With continuous checks, you would have sophisticated workloads. These checks and system improvements, alignment with best practices. If you have any questions, please contact with your local AWS staff. Let's summarize the session. I have covered in this session Line Mini application and AWS Serverless work very well to quickly implement and provide business logics and run feedback cycles. Serverless is less complicated, but there are things you have to pay attention. By using well-architected framework serverless application, you can check the status comprehensively and enjoy practical best practices. Please use AWS Serverless for Line Mini application and enjoy your developer's life. Thank you for your attention.